Hello, this is Craig Kozminski with this week's pre-lab video for experiment number 9, fuel value measurement. If you haven't done so yet, please pause the video and read through the 7 steps of this week's procedure, being certain to underline any key directions that you think will be vital for your success in this week's experiment. In short, we will be determining the fuel value of a gas by direct measurement of the heat of its combustion. And in doing so, what this will look like is we'll be using the same torches that we've used over the past weeks, most recently to combust the magnesium. And this time we're going to be using that fuel to heat a pot of water. And so we're going to be measuring the exchange of energy, the chemical energy stored in the bonds of the fuel, and how it gets converted to heat energy in the water, which is found inside of the pot. And so we'll be doing this 2 times, this experiment twice. And you'll see here in the procedure the slight distinction between the 2 iterations of this experiment. On your data table, which is found further down on page 88, you'll see that trial 1 of this experiment will be conducted using a small flame, and trial 2 will be conducted using a bigger flame. You'll be recording the type of pot that you're using as well as the fuel. You'll be measuring the mass of the calorimeter pan as well as the mass of the water. The initial and final mass of the fuel tank, the difference between that will give you the mass of the fuel that was actually combusted. And then we'll have our initial and final temperatures. You'll be calculating the heat absorbed in units of calories, and then you'll be converting that into kilocalories. This conversion factor is given to you on your calculation sheet. That is the second page of this week's experiment. And once you convert from calories to kilocalories, you'll be able to calculate your experimental fuel value. Your theoretical fuel value will be determined during the pre-lab portion of this week's experiment, and determining both your experimental and theoretical fuel values will allow you to determine the efficiency of the heat transfer during the experiment. To review some of those conversions and calculations, as it's been a moment, the change in energy, the change in heat energy delta Q is equal to the mass times the heat capacity times the change in temperature. As we did previously, we are going to be using a slightly modified version of this equation to account for the fact that we are not just heating the water, but we are also heating the pan. And so we'll be using this form of the equation to calculate our delta Q, where we have the mass of the metal being used, either copper or aluminum, times the heat capacity of that pan, plus the mass of the water times the heat capacity of the water. And we'll be multiplying the sum of these 2 terms times the change in temperature delta T. So this is how we'll calculate delta Q. Delta Q prime, if you will, is simply the delta Q converted into kilocalories. And then the equation for our experimental fuel value is our heat energy exchanged in units of kilocalories over the mass of the fuel consumed in units of grams. And this is going to be our experimental fuel value. One note about the exercise worksheet for this week's experiment. In this problem, it says, on a camping trip, a propane stove is used to heat 10 gallons of water to wash dishes. And the temperature rises from 20 degrees Celsius to 45 degrees Celsius. The water is heated in an aluminum pan having a mass of 1,600 grams. And you're given the the volume to mass conversion for the water. So you'll notice in the problem, you're given a volume of water, not a mass of water. So to calculate the heat energy gained, this is a bit of a mistake. It shouldn't say the heat energy gained by the water, but the heat energy gained by the pan and the water. So the calculation we'll be using is delta Q is going to be equal to the mass of our metal pan times its heat capacity plus the mass of the water times the heat capacity of the water times our delta T. So we don't usually give you the equations here for the exercise worksheet, but for this part A, I wanted to provide you this equation given that the way that part A is worded, you may have been tempted to just calculate the heat energy gained by the water and ignore the mass and heat capacity of the pan. So for this part, use this equation. And then you won't be able to solve part B or C until we've obtained some of our experimental values. So I hope this video is helpful in easing any anxiety that you may have about this week's experiment, and your instructors are looking forward to seeing you. Have a great day.